We now move to practice sums so that you understand where and how integration can be used in our in sums related to business, economics, or maybe in our practically in our day-to-day life. Okay. So today we are going to touch upon application of integrals. So you have this, unit 4, where you have this particular concept in detail. So in application of integrals, today we are going to touch upon different type of functions: revenue function, cost function, profit functions, demand functions, and all those things through sums. So I'm going to show you through sums how you can solve these different type of uh, functions. Okay. So we start with the first sum. It says, before that, let me tell you, if you remember, so there is something, if I say C, okay, if I say C as the total cost, then ddx of C is the marginal cost, or we can say it as MC. This is something which we have already learned in differentiation, that if you are given the total cost function and if we differentiate the total cost function, then we get the marginal cost. Now look at this sum. They are asking you to do the opposite. The marginal cost function of a firm is given, MC. Find the total cost of 100 units if the cost of producing 1 unit is rupees 22. Okay. So what they are saying is marginal cost function, which means this one, this is given to you. Marginal cost function of a firm is given to you, log x whole thing to the power x. Sorry, whole thing to the power 2. Now you are asked to find out the total cost. You are asked to find this total cost of 100 units if the cost of producing 1 unit is rupees 22. So when we do the sum, you will understand why this additional information is given. Normally, this additional information is given in order to find out the cost constant of integration. As you know that there is always a constant of integration. So that constant can be found out by using this additional information. Okay. So let's start doing it. We are given that marginal cost function MC is equal to log x whole square. Okay. Now MC we know is ddx of C. Okay. ddx of C, which is equal to log of x whole square. What is the C? You can write C is the total cost function. C is the total cost function. Okay. Now, if I cross multiply, I'll get DC is equal to log x whole square dx. What I did, just cross multiply the dx. So I'm having DC here and I'm having log x whole square dx. Now suppose I take integration both sides. So I'll get integration DC is equal to integration log x whole square dx. Okay. Integration DC is C and integration log x whole square. Now this we don't have any formula. Unlike differentiation, you have ddx of log x, but there is no integration of log x. So if you have log x in integral function, we normally do it by integrating by parts. How? We will take another expression or a function. We will write log x whole square into 1 dx. Okay. Now, if you remember the late acronym LATE, the first L stands for logarithmic function. We have a logarithmic function. So obviously, this will be our first function. And then we have 1. 1 is nothing but an algebraic function. Algebraic function can be in terms of variables or maybe in terms of constant. So 1 is a constant and that is an algebraic function. So obviously, log x will be your first function and 1 is your second function. So let's now apply integration by parts, this one. So here now we are having log x whole square, and this is 1. So what will happen on the right hand side? We'll write log x whole square and then integration of 1 dx minus integration ddx of log x whole square into integration of 1 dx dx. So that's the way how I'm going to write in the next slide as a solution to the sum. Okay. So this will be equal to C is equal to, you will get log x whole square. Okay. First function into integration of second minus integration of d dx of log x whole square, okay, into integration of 1 dx. This entire thing should be within curly bracket and we'll write a dx. Okay. So let me erase the top part so as to continue doing my calculation from the top. Okay. So we will get, this implies C is equal to. So let's go slowly and understand how to do this. So log x whole square will be log x whole square. What is integration of 1 dx? Integration of 1 dx is integration of dx. And integration of dx is nothing but x. Like d dx of x is 1, integration of dx is, x. So integration of dx is x minus integration. So here d dx of log x will be log x 2 into log x to the power 2 minus 1, okay, and then into d dx of log x will be 1 by x dx. I repeat, first we use the power rule of differentiation. Power rule says 2 comes to the coefficient and then log x to the power 2 minus 1, okay. Since this is not x, it is log x, so we have to apply chain rule, and in the chain rule we again have to differentiate log x. d dx of log x is 1 by x, and finally we have, okay, I made a mistake, 1 second. So let's redo it. C is equal to, we will get log x whole square into integration dx is x, then minus, this will be 2 log x into d dx of log x is 1 by x into, can you see there is an integration 1 dx, integration 1 dx is x into dx. So there it is. This is what we are going to get when we do this integration by parts. Now this x and this x gets cancelled. So we will get x into log x whole square minus 2 comes outside the integration sign, and what we are left with is again integration of log x dx. Now I told you that we cannot integrate log x. Okay, there is no direct formula. So this integral again has to be done through by parts by multiplying 1. So let's proceed. So we will get x into log x whole square minus 2 into integral log x into 1 into dx. Okay. So we will get is equal to x into log x whole square minus. So we'll apply again by parts, integration by parts. First function, second function. So we'll write first function into integration of the second minus integral d dx of first function into integration of the second, whole thing integration. So we'll get x log x whole square minus 2 into x log x minus, this will be integration d dx of log x is 1 upon x into integration of dx is x, and then we have dx. These two gets cancelled. So we are left with x log x whole square minus 2 into x log x minus. So this is integral dx, which is equal to x into log x whole square minus 2 into x log x minus x. Okay. So there we have reached to our final step of doing the integration. So this is C. Now there should be a constant. Okay. So we have x log x whole square minus 2 into x log x minus 1 plus C. So what we did through integration by parts, we have got our cost function. The question is, find the total cost of 100 units. Right now we have got only total cost function. So C is equal to x into log x whole square minus 2 into x log x minus 1 plus C. Here everything is known except for the constant. We don't know what is the value of the constant. So for that we will be using this information. It says if the cost of producing one unit means the value of x is 1. If x is 1, then the value of C is given 22. Okay. It is said if the cost of producing one unit is rupees 22. So we'll write this implies C is 22, x is 1, log 1 whole square, 2 into 1, log 1 minus 1 plus. Okay. So log 1's value is 0. So if log 1's value is 0, this whole thing will be 0. 0 squared will be 0. 0 into 1 will also be 0. Similarly, here we will get log 1 is 0. So we'll get only minus 1. Minus into minus will be plus 2. And here we'll get C. So we'll get 22 is equal to 2 plus C. Okay. 22 is equal to 2 plus C. So then what is the value of C? C will be equal to 20. So we will write, let's write here, therefore, C is equal to 20. If we shift 2 to the left hand side, it will be 22 minus 2. So the value of C is 20. So this information is given for you to find out the value of C. Now what we can do is, we can say therefore the total cost function is given by total cost function is C is equal to x log x whole square, then minus 2x into log x minus 1 plus, in place of C, we will write 20. This is our total cost function. But the question is asking you to find out the total cost of how many units? 100 units. Okay. So we'll say when x is equal to 100, C is equal to. So we have to do this 100 into log 100 whole square minus 2 into 100 log 100 minus 1 plus 20. Okay, so let's see what will be the calculation for this. 1 second. Okay. Quite a lot of steps involved, but the calculations are simple. But if you make a mistake anywhere, then it will be very difficult for you to get to the right answer. Okay. So we are getting C is equal to 100. Do you know what is log 100? Log 100, log 10 is equal to 1. Log 100 can be written as log 10 squared, which is 2 log 10. which is 2 into 1, which is 2. So log 100 is 2. Okay. So wherever we have log 100, we will write 2 square minus 200 into log 100 is 2 minus 1 plus 20. This is 400 minus 200 into 1 plus 20, which is 400 minus 200 plus 20. In other words, we will get 220. And that is your answer. So therefore, the total cost of 100 units will be 220. Okay. How did we do? Let's do a recap again. We are given marginal cost. And from the marginal cost, we can find out the total cost. Question is how? By integrating. So we have integrated, we have written MC as ddx of C, and we have cross multiplied dx, then we have integrated. That way we got a cost function, but the cost function had a constant of integration, which is C. To find out the value of C, we use this information that for producing 1 unit, that means when x is 1, then C is 22. So we solved and we found that the constant of integration C or K, whatever you write, is equal to 20. Now that value we are using in our cost function. So our cost function now becomes C is equal to x into log x whole square minus 2x into log x minus 1 plus 20. That is our cost function. Now if we look at the question, many questions ask you only to find out the cost function. So it should have been the answer. But this question is not asking you only to find the cost function. It is asking you to find out the total cost of selling 100 units. So after getting the cost function, we have to find out what is the cost when x is equal to 100. X is the total number of units produced, or you can say output. So when x is equal to 100, we'll put the value of x is 100, and then we'll do the calculation, and we got the answer is 220, which is the cost of producing 100 units of the commodity. So this is how we can do. Okay, the function of cost function. When the marginal cost is given, we can actually calculate and find out the total cost. Okay, hope that was clear.